Welcome back, Bear Scouts, for Activity 15, Super Science, Art Explosion, and more marble games. Hemphill, Camino Real, Blanco Vista Elementary, and all others are welcome.
For more fun activities at home, visit our YouTube channel, Sacred Springs Scout Reach. Please join me in the Scout Oath. On my honor, I will do my best to do my duty to God and my country and to obey the Scout law, to help other people at all times, to keep myself physically strong, mentally awake, and morally straight. Please join me in the Scout law. A Scout is trustworthy, loyal, helpful, friendly, courteous, kind, obedient, cheerful, thrifty, brave, clean, and reverent.
Show the Cub Scout sign. Tell what it means. Make the sign with your right hand. Hold your arm straight up. The two raised fingers stand for the Scout Oath and the Scout Law. The fingers look like the sharp ears of the wolf, ready to listen to a Kela. Remember that a Kela means good leader to a Cub Scout. Your mother or father or guardian is a Kela. So is your Cub Master or your den leader. At school, your teacher is a Kela.
Say the Cub Scout motto. Tell what it means. The Cub Scout motto is do your best. A motto is a guiding principle and a rule for living. Do your best means trying your hardest, not just a little bit. Do your best all the time. Do your best in school and at home. Do your best when you play a game and help your team. Do your best as you work on your rank adventures.
Super Science. Answering scientific questions. Scientists try to create a fair test when they want to answer a question. The steps below can help you answer questions like a scientist. Number 1, ask a question. What do you want to discover? Number 2, do research. What have other scientists already learned? Number 3, make a good guess at the answer. This guess is called a hypothesis. 4, test your hypothesis with an experiment. This is the fun part. Number 5, decide whether your hypothesis was supported by the information you collected. Number 6, share what you discovered.
Well, hi there. My name is Richard. This is my friend Jim, and we're here at Adventure Base Camp at Camp Champlain to bring you super science for Cub Scouts.
Have you ever wondered why the sky is blue, or how gravity works, or what makes a rainbow? Scientists wonder questions like that all the time, and they figure out the answers through experimentation.
Gravity check! It works. Now, the great thing about a lot of these experiments today are not only are they fun to do, but they use things that are gooey, oozy, splishy, and splashy, which are just the kind of things that Cub Scouts enjoy doing.
In this adventure, you'll get to do some science projects that are a little bit messy and really amazing.
So, put on your lab coats and get ready to do some super science. Scientists try to create a fair test when they want to answer a question. The following steps can help you answer questions like a scientist.
Step 1, ask a question.
What do you want to discover?
Step 2, do research.
What have other scientists already learned?
Step 3, make a good guess at the answer.
Okay, this guess is called a hypothesis.
Step 4, test your hypothesis with an experiment.
And that is the fun part.
Step 5, decide whether your hypothesis was supported by the information you collected.
Yeah.
Step 6, share what you discovered.
Always share what you discover.
Our first experiment is all about static electricity. You may have walked across a carpet floor in your socks to pet your dog and gotten a shock. Maybe you've taken off your winter hat and found that your hair was standing straight up in the air. These things happen because of static electricity.
To understand static electricity, you have to understand atoms. I love the atom. He's that guy from Legends of Tomorrow, right?
Yes, but wrong Adam.
Wrong Adam, not the superhero?
No, different kinds of atoms.
Oh! You know what? Everything around us is made up of very small things called atoms. Those atoms are made up of even smaller things, including protons and electrons. Protons have a positive charge and electrons have a negative charge. Each atom usually has the same number of protons and electrons, but if two atoms bump into each other, hey, Jim, did you hear about the two atoms that walked into a bar?
No.
Well, you would think one of them would have seen it. Anyway, if they happen to bump into each other, electrons from one atom can get rubbed off onto the other atom. As you walk across a carpeted floor, especially if you happen to drag your feet, extra electrons build up on your body. When you touch your dog, those electrons jump onto the dog, causing a little spark of static electricity. Why does your hair stand up when you pull off your winter hat? That happens because all your individual hairs now have a positive charge and are repelling each other. This is kind of like trying to hold the positive sides of two magnets together. For this first experiment, we're going to blow up a balloon, and then we're going to rub it against different objects to see how each object reacts to the balloon and the static electricity. So, my friend Jim is blowing the balloon up. He's using a helium tank. Hey, if you've got the lung power, you might as well use your own lungs to do it, but we're using a helium tank today. And as soon as he is ready with this balloon,
Longer than I expected.
this just takes some time sometimes, when you don't practice the experiment first and then you just stand here talking. Look at Jim, he's so good. All right, so Jim.
All right, we're gonna rub it against this bowl fleece blanket. On your hair or my hair?
Oh, you can use my hair. It's thin and see what happens. So see what happens with my hair. Oh, rub it against my hair.
Hey.
See that? See what happens? There we go. All right. Okay, yeah, it's a look. Okay. Thank you very much. Wow. Makeup, hair. Okay, now hold it up to the blanket and see what happens. Oh, look at that. It stays and attaches itself. Now let's see. We're going to try other objects. Now take it off the blanket. There we go. All right. Let's see. What happened to Arizona can? Oh, helium's making it float away.
Try a full one.
A full Arizona can. Let's see what happens here. That same thing. It's still floating away. Quick, halt! Jim!
No, it's just gonna keep being up there. What do you think was gonna happen?
Okay.
Come on.
We're gonna bring this. What's gonna happen?
Hey, we did it.
Look! We got it! So, now, let's see what happens now that my hair's standing up. If I try to attach it to a glass cylinder. Nothing. Okay, we're not gonna let. How about a feather? Nope. Look! Sticks to the Boy Scout uniform. Like I say, if your parents will let you, you can try to use this balloon, your balloon, to try to see how it reacts to different objects around the house.
Our next experiment is all about sinking versus floating. Whether an object sinks or floats in a liquid depends on two things: density and buoyancy.
Density is how close together the molecules of an object are, or how much mass a substance has in any given space. For an object to be buoyant, or float, it must have less density than what it is floating in, or it has to have something attached to it that helps it float.
Step 1. Fill all 3 cups half full with water. Step 2. Stir salt into the first cup and sugar into the second cup. Now, leave the third cup alone. Now think about what will happen when we add an egg to each cup. Do you have an idea? Now gently add the egg to the cup. This experiment shows how scientists use variables. A variable in an experiment is the thing that changes. And by changing just one variable at a time, we proved how sugar and salt affect how eggs float in water.
Now, the plain water is called the control because it doesn't change. And since the control is the same in each one, we can compare the results with the salt and the sugar and the plain water.
For our next experiment, we are going to be learning all about color morphing. For this experiment, we will be using a large jar or clear vase, enough water to fill the jar halfway, a measuring cup, a spoon, 2 tablespoons of cooking oil, and 3 drops each of red, blue, and yellow liquid food coloring. Step 1. Fill the jar or vase halfway with water. Step 2. In the measuring cup, mix the oil and the food coloring together. Next, pour this mixture slowly into the water and watch what happens. Now what is happening here? Since food coloring is water-based, it will separate from the oil and float through the water in amazing color morphs. If you have time, try different color combinations. To keep the color theme going, we are going to be doing a color layering experiment next. And for this experiment, we will be creating a rainbow in a cup using sugar, water, and food coloring. The materials we will be using are 15 tablespoons of sugar, 15 tablespoons of warm water, red, green, blue, and yellow liquid food coloring, 6 clear containers, and a spoon. First, put 5 cups in a row on the table. Add 1 tablespoon of sugar to the first cup, 2 tablespoons to the second cup, 3 to the third, 4 to the fourth, and 5 to the fifth. Then add 2 tablespoons of lukewarm water to each cup. Stir until most of the sugar dissolves. Add a drop or 2 of food coloring to the first 4 cups, 1 color per cup. In the 5th cup, mix 2 colors. Now take the 5th cup, the one with the most sugar, and pour half of its contents into the empty cup. Hold the spoon, bowl side up, against the inside of the 6th cup. Then slowly and gently pour half of the contents of the 4th cup into the spoon. Pouring onto the spoon keeps the 2 liquids from mixing in the cup. Do the same thing with the 3rd, 2nd, and 1st cups. What is happening here? Adding sugar to the water causes it to become denser as the sugar molecules take over the space. The more sugar you add, the denser the water becomes. That's why you can stack the colored water as long as you pour it gently.
We are so glad you decided to join us today here at Adventure Base Camp at Camp Champlin. Once again, my name is Richard. This is my friend Jim.
Remember, a scout is thrifty.
We hope you have as much fun doing the experiments at home and even more fun than we did putting them together for you.
And we'll see you next time.
Ow!
Testing static electricity. Which of these objects will stick to a balloon or comb? Write down your prediction and then write down what actually happened. Object, prediction, result of investigation. Tissue paper, aluminum foil, cardboard scrap, paper scrap, yarn or string, pom-pom, chenille stem, ribbon, cloth, foam, coin. Requirement 3, conduct one other static electricity investigation. Explain what you learned. For this requirement, fill a dry, empty plastic bottle with small foam beads, like the kind in a beanbag chair. Stand in front of a mirror and rub the bottle on your head. What happens to the beads? Now touch your other hand to the bottle. Do the beads move toward your hand or away from it? Experiment with other objects to check the reaction of the foam beads.
Mixing paint. A fun thing about painting is mixing paints to create different colors. From just a few basic colors, you can create just about any color for your paintings. Look at the color wheel on this page. The primary colors are red, yellow, and blue. The secondary colors are orange, green, and violet. You can mix equal amounts of yellow and blue, primary colors, to make green, a secondary color. If you add more yellow, you will get yellow-green. If you add more blue, you will get blue-green. To make a color lighter, add a small amount of white. To make it darker, add a little black. If you're not sure about a color you've mixed, try it first on a piece of scrap paper. The more you paint, the more you'll learn about mixing colors. Art supply stores sell paints in many colors. After working with the primary colors, you may decide to buy a few other colors to see what they are like. Experiment. You can use a brush in many different ways. A wet brush makes a different pattern from a mostly dry brush. If you lay the brush flat, it will leave brush marks on your paper or canvas. If you touch just a tip to the paper, it will leave dots. You can also use tools other than brushes. A sponge dipped in paint adds texture. A string dragged through paint and pressed down on the paper or canvas leaves a line. Crumpled paper dipped in paint makes interesting patterns. You can even mix different materials. For example, you could use crayons for the lines of a drawing and then brush on watercolor paint in some areas.
Your own picture. Paint a picture 2 different ways. Paint it once the way you usually would paint it, and paint it again by using a blindfold. Discuss with your den or family the ways the process was different.
Requirement 4. With the help of an adult, make a marble bag to hold marbles. To keep track of your marbles, it helps to have a good container for them. For this requirement, you will make a drawstring bag to hold your marbles. Here's one way to make a bag. You will need a piece of fabric about 5 inches by 9 inches, needle and thread for sewing by hand, or a sewing machine and an adult to help operate it, a safety pin, a shoestring or piece of cord about 3 feet long, and scissors. Procedure. Fold the long ends of the cloth over about 1 inch and make a crease. Sew along the cut edge of the fabric and form 2 pockets. Fold the fabric in half so that the printed side is on the inside. Sew along both edges, but not over the pockets you formed in step 1. Attach the safety pin to one end of the shoestring or cord. Put the safety pin in the end of one of the pockets and push it through the other end. Next, put the pin in the closest end of the other pocket and push it through to the other end. Remove the safety pin and tie the ends of the shoestring or cord in an overhand knot. Turn the bag right side out. Fill the bag with marbles. To close it, scrunch the fabric at the top together and tie another overhand knot where the shoestring or cord comes out. Marble Madness. Plums. This game is for a small number of players. Draw 2 parallel lines about 6 feet apart. Each player puts the same number of marbles, called plums in this game, on one line a few inches apart. The players stand behind the second line. Players take turns shooting at the plums from behind the second line. They keep any plums they knock off the line. Keep playing until time is up, if a time limit has been set, or until all the plums have been picked. The player with the most marbles is the winner. A scout is friendly. Everyone will have more fun when you play by the rules to keep the game friendly. Dropsies. This game is good for 2, 3, or 4 players. Draw a square on the ground about 2 feet long by 2 feet wide. Each player places 5 marbles inside the square. The first player stands on one side of the square with his feet outside the line. He drops a shooter from above waist height onto one of the other player's marbles to try to knock it out of the square. If he does that and his shooter stays in the square, he keeps the marble that rolled out, and he gets another turn. If he does that, but his shooter also rolls out,
He keeps the marble that rolled out and loses his turn. Keep playing until time is up or most of the marbles have been knocked out. The player with the most marbles is the winner. Requirement 3. Learn 4 or 5 words that are used when talking about marbles. Tell what each of the words means and how it relates to playing marbles. Share this information with your den or family. Like many games and sports, the game of marbles uses some special words. You've already learned some of them, like shooter and alley marbles. Here are some more. Bombies is when you drop your marble onto another marble. Dubs is when you knock 2 or more marbles out of the ring with one shot. Keepsies is when you get to keep the marbles you win in a game. Don't play for keepsies if you don't want to lose your marbles. Friendlies is when you give back the marbles you won at the end of a game. Knuckle down is when you put one knuckle of your shooting hand on the ground as you shoot. Histing is when you lift your knuckle as you shoot. What marbles words do you and your friends use? Requirement 5. With your den or family, make a marble obstacle course or marble golf course. Share what you create. Invite everyone to go through your course. Shooting marbles in a straight line and at a target is a lot of fun. Shooting around or between objects helps make the game more challenging. Marble obstacle course. Gather some objects from around your house like blocks, paper towel tubes, yardsticks, and pillows. Use them to form an obstacle course for you and your friend to shoot marbles through. For extra fun, have your course go down steps or over obstacles. See who can be the first to reach the end of the course. Marble golf course. Marble golf is like regular golf. Shoot from one hole to another, counting the number of shots it takes. The object is to get to the last hole with the lowest number of shots. Try to improve your score each time you play. For an outdoor marble golf course, make indentations in the dirt for your holes. For an indoor marble golf course, use pieces of paper on the floor as holes. A marble is in the hole if it stops on the paper.
Join us next time for Activity 16. Pause for action, create a marble maze, and marble racetrack. If you are interested in joining a pack near you, visit beascout.scouting.org.